Alright, so right now we're going to turn our attention from the pigs to the goats. Bah! I gotta tell you, one of the funniest, the hardest I've ever laughed is when someone showed me that Taylor Swift video with the goats. It was hilarious. Alright, so we have food consumption of a goat, and apparently the food consumption of a goat is related to the temperature outside. So the hotter it is, the less they eat. That is interesting. So we were to make a table of the graph and draw a line of best fit. All right, I can do this. Excellent. So the first variable is temp. So that has to go on the x-axis, which means food eaten has to go along the y-axis, and this is in kilograms, and this is in Fahrenheit. Now that is sort of weird, because if we're talking about a metric system like kilograms, you would expect the temperature to be in Celsius. Oh well. So I'm going to start at 0 degrees. Is it possible to have a temperature of 0 degrees? Absolutely. So we're going to start with 0 and 0, and we need to go from 0 to 90. So, I'm going to skip. So 5, 10, 15, 20, 30, 25, 30. 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. That makes this 100. All right. So just want to make sure that each line is worth 5, and I'm only writing the tens. All right. So food consumption. Now this one's going to be a little trickier because obviously the least a goat can eat is 0 kilograms. It goes up to 4 or 5 kilograms. So you know what? I'm going to count by 4. So 1, 2, 3, 4. So that's 1 kilogram. 1, 2, 3, 4. 2 kilograms. 1, 2, 3, 4. 3 kilograms, 1, 2, 3, 4, 4 kilograms, and 5 kilograms up here. All right, so here we go, 30 degrees and just about 4 kilograms. So that's going to be right about here. And that is 30 degrees, all right. So then 40 degrees and 3.6 kilograms. That's just a little more than 3.5 kilograms. So there's 3, 3.25, 3.5. My pen calibration's off just a little bit, so it's causing some issues here. All right, so 45 degrees Fahrenheit and 3.4. So we can do 45. That's all right. 45 and 3.4. So that's just under. It is starting to become a line, isn't it? So then we have 55 degrees and 3. So that's going to be right about 55 degrees and 3 right there. That dot means, that dot means nothing. All right, so then we have 60 degrees and 2.7. So 2.7 is just a little bit more than 2 3/4. Then we have 75 and 2.5. Well, that's an easy one to find right about here. And this really is linear, isn't it? 80 and 2.2. 80 2.2 is just less than 2 3/4 right there. Oh my goodness. And finally 90 and 1.9. So as it gets warmer, the goat needs less food. That is interesting. All right, so now we can make a line of best fit because this data is super linear. Is it exactly linear? No, but it doesn't have to be exactly linear. It just needs to be close. All right, so one's a little bit harder for the ruler to do here. That looks actually pretty close, I'd have to say. All right, now this line of best fit is going to give us fits because it doesn't really go through grid points very well. So what I'm going to do is I'm going to strategically place this so that I can better find the slope. So I'm going to use that point right there. I'm going to use that point right there. And then I'm going to rotate this so that it goes through this point right there. So here we go. All right, and so the points that I'm going to be using right there and right here. All right, so now I can make my slope triangle. All right, so how far down? So we went from 3.75 down to 2. So that's a difference of negative 1.75. How far over? So that's 35. And that goes to 90. The difference between 35 and 90 is going to be 55 degrees. So that means my slope is going to be negative 1.75 degrees, or so that's kilograms, over 55 degrees Fahrenheit. So that's going to be my slope. My y-intercept is just under 5 kilograms. So I'm going to be looking at food eaten, F for food, is equal to 1.75, negative 1.75 over 55. And then we're going to multiply that by the goat. I need to move the goat or else he might eat our equation. So I'm going to multiply that by temperature. And we need to add to it. I would say that's what? 4.9? 4.9. That's going to go into the garbage if I get any closer. All right, so the next question says, what do M and B tell us? Well, the B tells us that if there is a temperature of 0 degrees Fahrenheit, that the goat will eat approximately 4.9 kilograms of food. That's a lot of food. And then the M value tells me that for every 55 degrees of temperature increase, the goat will eat 1.75 kilograms less. Now, that's still a hard number to wrap my head around, so it would be totally appropriate to go 1.75 divided by 55 and get, so that means for every degree Fahrenheit that the temperature goes up, the goat will eat 0.03 kilograms less. That's interesting. Okay, use your equation to predict how much a goat would eat on an average temperature day of 50 degrees. All right, so we're going to multiply this by 50. All right, and remember that's going to be negative, and we're going to subtract our 4.9. All right, so I totally didn't do that right. So we have 1.75 divided by 55. We're going to multiply that by 50 because our temperature is 50 in this case. And that piece is negative. And we're going to add it to the amount that it would eat if it had a temperature of 0. And so we'd expect to eat roughly 3.3 kilograms. And lo and behold, if I were to use my graph, That looks about right, 3.3 kilograms. All right, how about 70? Okay, well, we'll do our 1.75 times, divided by. That's a negative. Divided by 55. Now we multiply it by 70, because it asks us to do that. And then we're going to add it to our 4.9. And so at 70 degrees, it would be about 2.7. Let's see. Yep, that's right at 2.7. So our equation works. Look at that. Winner, winner, chicken dinner.